Hello everyone, this is Team Pylon here, and our presentation is focused around the level of service for California's highway systems. Let's begin with a list of our team members. There they are. Moving forward into our agenda for today's presentation. Okay, let's dive right in. From the start, we wanted a project idea that was applicable to the real world and had some impact on people's daily lives. Caltrans offered the best solution as traffic congestion plays a large role in our lives. For those of you that don't know, Caltrans is responsible for the aeronautics, highway development, and transportation planning throughout all of California. This project originated with the help of Caltrans District 6. District 6 is comprised of Madera, Fresno, Kings, Tulare, and Kern counties. Our overall goal was to produce a testing method to calculate the level of service for California's highways more efficiently as new data becomes available. Major projects like freeways, highway windings, and interchanges are initiated based off the highest level of service and hotspot analysis. Complicating things more, Caltrans does not have time nor the staff needed to study every segment within the national and state highway systems to accurately indicate where projects are truly needed. This results in facilities being constructed where they are not as needed in comparison to other locations, usually costing more than $50 million in state funds. Our project goal is to analyze data from prior years and come up with a model to calculate the level of service for future implementation. By doing this, we aim to reduce the highway development in locations where new development is less impactful on traffic congestion by making assumptions directed by Caltrans with certain values and then testing whether it is viable to make these assumptions based on our traffic results.
Level of service definition. According to the Highway Capacity Manual, level of service is a rating system that measures the quality of service on a roadway. It is actually broken up into 6 different categories. They range from A to F. A and B are categories that are too over-designed. C is a category that is acceptable but may still be over-designed. D is a main goal. It is a middle ground between being under-designed and overkill. E is borderline fail. They have to take a look at different factors that also play a role in level of service to determine if it is under-designed. F would require a lot of attention and it is not good. In this stage, it is under-designed. Now we are going to look at the 6 different levels. Level of service A shows that there is a free flow. There are low amounts of traffic and drivers do not affect each other. Level of service B is reasonable free flow, stable amounts of traffic, and drivers are slightly affecting each other. It is good to take into account that in both of these stages, it is still considered over-designed. Level of service C is stable flow. Traffic flow becomes restricted and drivers often affect each other. Level of service D, which is the main goal, is approaching unstable flow, but traffic flow is heavily restricted, but again, it is still stable and it's good. Level of service E is fully saturated flow. Traffic flow becomes unstable and is at or near capacity. Level of service F, however, is oversaturation. So in this stage, traffic is becoming forced and it is exceeding capacity of the highway. And it is good to take into account that both of these will be under-designed.
And now for our data sets. So our data was provided by Caltrans, and we used 2 Excel sheets for this project. Both Excel sheets contained hourly traffic information from every California highway. One Excel sheet contained hourly traffic information, while the other contained only hourly traffic information for trucks, as this would be needed to calculate level of service. So here we have an excerpt from our data set, and over here you can see AM01 and AM02, which correlate to the hour and the day. These values are the average traffic count over the course of a 3-day period within that hour. And here you can see Route 99, which correlates to Highway 99, and District 6, which equals District 6, which we're working on for this project.
The first thing we did for Descriptive Analytics was graph the volumes along the same section of Highway 99 for both AM and PM, left being AM and the right being PM. The same pattern is shown between these charts where from 2015 to 2017 there is an increase in traffic volume and there is a decrease in traffic volume from 2017 to 2018. The next thing we did was graph the hourly traffic rates for the same section of road. This would allow us to identify the 4-hour interval where there is the most traffic, which for the AM was found between 9 a.m. and 12 a.m. And on this chart shows the PM values for the same road. And the 4-hour interval with the most amount of traffic is from 2 p.m. to 5 p.m. These are the formulas used to calculate level of service. The end goal would be to get density, which would then be referenced to a chart to determine the level of service for the road. And density is calculated by taking the flow rate over the speed limit for the road. The formula for flow rate takes the highest hourly total traffic volume over peak hour factor times number of lanes times the driver population adjustment factor and times the heavy vehicle adjustment factor. Peak hour factor is calculated by taking the 4-hour interval over 4 times the highest traffic volume for an hour in that interval. And heavy vehicle adjustment factor considers the percentage of trucks and the estimated equivalents to passenger cars for those trucks, and the same thing for RVs. After we find density, we would reference this chart to determine the level of service for the road to see if it's in the A, B, C, D, or E category. And after we found level of service, we did an alluvial chart to see the transition of level of service from the AM period to the PM period. And it is noticeable about this chart that a large portion of the B level of services either shift to A or C during this time, from morning to night.
We perform predictive analytics to view the possible changes of LOS from previous years to 2020. Here we can see that the majority of LOS for Highway 99 and District 6 fell under the category of either A or B, which means that these portions of the highway were over-designed, and this is not a good sign. By using previous data, we were able to predict the level of service for Highway 99 and District 6 and see that there was not much of a change coming into 2020. Here we completed an analysis of LOS excluding highway ramps to see the effects that highway ramps play when determining LOS, and you can see that the ratings B, C, D, and F increased significantly as there were no more A ratings. And here we have the forecasted LOS for 2020 where no highway ramps were included, and you can see there is not much of a change for 2020.
Now this following alluvial chart shows a different way to visualize the change in LOS over a year. Here we can see that LOS from 2019 to 2020 doesn't change much, with most of them remaining in the A range, with a few of them sliding down to the B range, and the same for the other letter variables. Next one's a little different. This is a chart showing the accuracy of a KNN predictive algorithm we ran trying to predict LOS. It shows the actual LOS versus the one that the algorithm predicted. So we can see it's mostly accurate, with most of it being predicted correctly here in the A range, with a few being predicted wrongly in the B range, and the same for the other variables. It has a 74% accuracy, which is good, but this algorithm has a few problematic inaccuracies. For example, if we look here at the F range, we can see a lot of them get predicted correctly, but a few of them get predicted in the B range, which is far better than the F range. This could be a problem for Caltrans. If they look at a predicted LOS of a road in the B range, they might think the road is in a good condition when it's actually not. Now for some prescriptions we have to Caltrans. First, improve the modifier used to calculate LOS. The modifier provided to us was of 2.5% increase in volume over a year, while the actual increase calculated by us was of a 5% on the AM period and a 10% on the PM period. So here shows the percent increase in volume over the years. Also, some other possible improvements would be to perform better data collection. What I mean by that is to structure the data better. The data from the traffic data set and the data of the truck data set a lot of the time referred to the same road, but there was no key linking them together. By structuring the data better, it would be easier to make a better analysis. Second, would be to utilize density as a second parameter for determining the rows that require work. For example, code of LOS-E ranges from density 36 to 45. But there's a difference between the quality of the road for a road on the 36 density versus a road on the 45 density. To conclude, we found some interesting things. We found that the difference in LOS, if we remove ramps from the dataset, is extreme, with removing all A's from the dataset. We found volume out of all the variables in our dataset was the one that impacted LOS the most. We also found that peak hours are different than expected, where most of the time you would expect peak hours to be during rush hour, but we found that in a lot of cases it's not. We also found that Caltrans's modifier for predicting LOS, it's widely different than the one we calculated. And we also found that there's a difference in the LOS of a road on the AM period versus the PM period. Finally, we would just like to thank Dr. Peruse for approving this project, as well as everyone in Caltrans for providing us with the data we needed and the information necessary to complete this. Thank you.